Hello everybody, welcome to my Apache Hadoop series. I'm Venkat. Guys, here I'm going to start the basic introduction on how HDFS MapReduce in Hadoop system works. So, this is my first video which covers the description of Apache Hadoop. Later on, I keep posting videos on how to work on HDFS, how to work on you know MapReduce, like how to write a MapReduce, basic MapReduce program, and then making a jar and putting it to HDFS and running data into HDFS, all this stuff. Okay, let us start with Apache Hadoop, assuming that everybody knows the distributed architecture model of computers. Okay, let us start, guys. Apache Hadoop. It is an open source software project that enables the distributed processing of large datasets across clusters of servers. It is designed to scale up from a single server to thousands of machines with a high degree of fault tolerance. Hadoop was derived from Google MapReduce and the Google file system. Yahoo was the originator, everybody knows that, and has been a major contributor and uses Hadoop across its business everywhere. Other major users include Facebook, IBM, Twitter, American Airlines, NY Times, LinkedIn, Nielsen, and many, many more. A key aspect of the resilience of the Hadoop cluster comes from the software ability to detect and handle failures at the application layer. Two main subprojects are there in the Hadoop. Those are HDFS and MapReduce. This MapReduce, this is a framework that understands and assigns the work to the nodes in a cluster. HDFS is a distributed file system that spans all the nodes in the Hadoop cluster for the data storage. HDFS links together the file system on many local nodes to make them into one big file system. HDFS assumes nodes will fail, so it achieves reliability by replicating data across multiple nodes. Hadoop is supplemented by an ecosystem of like Pig, Hive, Zookeeper, I didn't mention here, but all these that extended the value of the Hadoop and improve its usability. That I'll be showing the Hadoop stack so that you can understand. Hadoop changes the economics and dynamics of this large-scale computing world totally. Okay, so this the facts I said the scalable. This is I mean how come I mention all these factors because the scalability comes it boils down into four main characteristics that is scalability, fault tolerant, flexible, intelligent, and like even cost effective. All this. How it is scalable? New nodes can be added as needed without needing to change the data format or how jobs are written or the applications on top. It is cost effective because Hadoop brings massively parallel computing to large clusters of regular servers. The result is sizable decrease in the cost per terabyte of storage, which in turn makes analyzing all of your data affordable. It is fault tolerant. When you lose a data node, the system redirects work to another location in the cluster and of the another node in the cluster. It could be the same rack or different rack and continues the processing without missing a single bit. We call it as a beat. We'll know what is a beat later. It is flexible because Hadoop is schemaless. It can be absorbed by any type of, it can absorb any type of data, structure or non-structure from any number of sources. From multiple sources can be joined and aggregated in many, many ways, enabling deeper analysis than other systems can provide. With this Hadoop, the data management and analytics is stepping into another different world. So what is the main actor in the Hadoop name node, which is a metadata server, which holds on the memory of what data is there in what nodes, in what blocks, and how to distribute them into the data nodes. All these things will be handled by the name node and the job tracker. Okay, we'll come to know about the job tracker and task tracker, which is a terminology we'll use in the MapReduce environment, and name node and data nodes uh, is the you know actors in the HDFS environment. I mean, we'll slowly understand what are these. Mainly, MapReduce is the heart of the Hadoop. It is, a programming paradigm that allows for massively scalability across hundreds or thousands of servers in Hadoop cluster. MapReduce separates and distinct tasks that Hadoop program performs by map jobs, reduce jobs. Map jobs are like key value pairs, which is basically the data processed to produce, uh, a uniform sets of data, which is a which resembles a hash map, like key value list. I mean key value pairs. So reduction job. It takes those key value pairs and then combines or aggregates them to produce the final results. Okay, first see the Hadoop technology stack. So Hadoop has main core or common things, which is HDFS and MapReduce yarn. Yarn is yet another resource negotiator, which is actually MapReduce version 2.0. It's a rewrite of MapReduce 1. It changes the architecture a little bit than the old MapReduce. Like previously, job tracker, task tracker, job tracker sits on name node, task tracker sits on all data nodes to like manage resources, scheduling, and also all and also tracks all task trackers. Yeah, and it breaks down into sub-levels. That is the one for specifically managing the resource, and the second for managing the jobs. Here, these are the different supplemented ecosystem for the core Hadoop. When we come to the data access layer, I mean, those are the supplements which we have for Hadoop to make our life easy. Like writing the MapReduce programs is very, very low level and makes it very tough for a typical non-Java guy or a guy who knows more SQL. Um, he can't enter into the Hadoop because of this obstacle. So here we got the data access technologies, Pig Hive. Pig is a high-level data flow scripting language. Not more keywords in it. It is like having two core components, Pig Latin and Pig runtime. Pig Latin is a programming language. Pig runtime is a compiler. Like it compiles Pig Latin and converts into MapReduce job and submit to the cluster. Like getting the data, loading it up, transforming the data, returning or storing. This is the main function of the Pig. Similarly, Hive gives a view of databases and the data warehouse on top of a Hadoop. It's a query language, HiveQL, which is similar to SQL. Basically, this was introduced for SQL-friendly environment. Like people who knows SQL more can easily understand Hive and can process anything with Hive. But like Hadoop has this one more data storage layer on top of it by HBase or Cassandra. So what if we need to write or read on a specific data in the batch processing? You know that Hadoop is for batch processing, right? So if we want to read or write specific data in this whole batch processing environment, it's not like possible by just the core component. So we come to HBase here. HBase is you might be hear a term called NoSQL, which is very buzzing word in the current day, which is like it doesn't mean that it doesn't have SQL. Like It like it underlines the structure of the databases are not strict. They're very loose, very flexible, which makes them very scalable. One of the most popular you might be heard is MongoDB. Easy to work with. It's a document style storage model, and programmers can take data models and classes like objects and serialize them while into MongoDB with the same ease bring them back onto their apps. So this HBase is a column-oriented databases which is based on the Google big table, like millions of columns, billions of rows, put indexes with them, and and one more important thing is Pig and Hive natively integrated on this HBase. This Cassandra is introduced by Amazon for their DynamoDB storage, which is designed for real-time interactive transaction processing on top of our Hadoop cluster. Both solve different problems and both require seeking against our Hadoop data. Programmers can use whatever they want based on their need. So interaction, visualization, and execution development. We have a hcatalog, Lucene, Hama, and Crunch. Hcatalog, metadata table and storage management system. It is a way to focus to create shared schemas, way for our tools, Pig, Hive to interoperate. It's it's like to have a consistent view of data across those of all the tools we have. Basically, it is a management for the storage, how we have to manage the data in this big environment. So Lucene is a similar, it's a full text searching uh, loaded with a uh, many loaded with like standard full wildcard searching, phase searching, page searching, like range searching, full text searching, all these type of main text searching uh, will be handled by the, will, the Lucene is introduced for main this text searching. Hama, it's a book synchronous processing. If we want to work for large amount of scientific data, we can go for Hama. Crunch, it's writing, testing, running MapReduce pipeline. MapReduce combines shuffles. I mean, maps, it reduces, combines, shuffles, help joining in aggregation of data. Crunch is a good tool. We can use Crunch for all these purposes. Data serialization, a way that we can take data from application, packaging it up into a format we can then either store on the disk, send across wires, use it in another application, or deserialize into format that you can understand like JSON or XML, binary format. You can make move of the data. You can always use the data in different cluster of pieces or different environment. For that, we have Avro, Thrift. Like Avro is a Hadoop essential framework for data serialization, and Thrifty specific creating flexible schema words with Hadoop. It's specific for cross-language compatibility. Like language and like language neutral serialization framework. It's an app that built it on Hadoop with Java. I mean, you want to use those same objects in another app built in Ruby, Python, or C++. In that case, you can definitely go for Thrift. Data intelligence, like with Drill, Mahout, are designed to interactive data or interactively work on data or nested data. Mahout is a machine learning library that consists of recommendation, clustering, and classification. These are the three aspects of Mahout. Um, this clustering, why to group related text and documents is, it's a way to, group the related things like all text and related. um, all texts are different, all documents are different. Like it will group the data. Mouth is very good intelligent mechanism. Um, if we see Amazon uses it like for the music sites, it separates the music, and for books site, it separates for books like that. Data integration environment, Scoop, wonderful tool. Scoop is used to deal with external, relational world with the Hadoop. The data storage mechanisms and everything is different in Hadoop in the outside relational world. So Scoop comes in between and sits between here and exchanges the data either from Hadoop to real relational world or from relational world to Hadoop. That's it. You can get anything with Scoop. You can interact the external world with Scoop. Scoop is very good. So I like Scoop. And Flume. Flume is like mainly a real-time log processing tool, which is like it keeps mountains of log data. By using them, we can push into Hadoop and do some real analysis like that. So you can always use them to break the malicious behaviors against the things like our web server. So data managing and monitor orchestration, which will be done by Zookeeper and Oozie. Zookeeper, which is a very good environment. I mean, Zookeeper is like it has a leader and volunteers, and they help us to make uh, the data managed properly in the Hadoop system. Um, for example, if the data from one node has been delayed, or from one node the data it takes more time. It needs the data to stay, the reads, writes, all this. There should be one tool which helps us to manage all this data, which is Zookeeper, Oozie serves this need. See, workflow library allows us to connect with a lot of these essential projects, run and quick scripts, like the kickoff high query, then a scoop job. I mean, that that's what Uzi allows us to do workflow. I mean, what to do first, what to do second, what to do third, and maintain them, manage them, all those things. And now, like this, just basic introduction to what this Hadoop stack and what are all these names comes under, and what is the relation between the core Hadoop with all those things. That is what I clear here. Okay, let's start with HDFS introduction. It's a master-slave architecture. It contains a master and many slaves. The master is typically name node and slaves are data nodes. This name node controls all the data nodes. In MapReduce world, we have a job tracker which controls all task trackers. Okay, come on to like name node. It handles and manages file system operations. Like it does block mappings. Whenever a file comes into HDFS, it breaks down and distributes into all the nodes, data nodes, and then let them know what block and let them fill with their available blocks slots. It knows where all the data for a particular file needs. Like data nodes actually doing operations as commanded by the name node. So it doesn't. They always follow what name nodes say. Let us see this. And retrieval process. Let us understand how this retrieval also happens. First, the client says to name node, "Hey, name node, I want this file A. So get me the file A." So name node will search the file. Say, I think this is file X. Okay, I'm sorry. Okay, file X. So file X it has the metadata of file X. Come on, rack A, data node 1. In your slot 23, you have my needed data, get me the data. That's it, boom, it will get the data. Parallelly, it also calls, right? G, you have data node 3 and data node 2, which has data node 3 has a slot 54. I need that slot, man. And data node 2, you have some slot. Come on, give. You need, I need this slot, guys. Boom, they'll get all the data. Integrates again, and then back to client. Take your file, Mr. Client. This is how it retrieves. HDFS features, it's a mainly rack aware, reliable storage, high throughput. We'll see why I said all this. Like, what happens if we lose an entire rack? Name node ensure multiple data replicated in multiple nodes. So that, replication means copying the same file into different same file twice or thrice. Typically, Hadoop makes a replication factor of thrice. I mean, if we lose the data, we always have a backup. We always have a replication. So it's not a fault system. It's a fault tolerant system, rack aware system. It's reliable. So ensure replication factor makes it stable without any loss. So it has a high throughput. We'll see what is this throughput and how this throughput really matters here later. So come on, name node. Name node is a uh, it's a it's a it's a master which contains the file system metadata, which doesn't really store the data, which stores the metadata of the data, and it's like it it helps in making the data distributed across multiple nodes and retrieve them back whenever the client needs. Data nodes and the secondary nodes always talk to the name node, like what you want, where, what are the slots, what data you want me to grab, and like, hi, I'm working, this beat, like I'm saying, this dead node sends a heartbeat every 3 seconds. If it is greater than or equal to 10 seconds, name node will think that's a dead node. So then like it thinks that the node is dead, and it will make another route and calls another node, and makes the whole flow continue. Interact communication, it places the blocks, it places the data into the slots of the blocks nearby to make a network with high throughput. It plans in such a way that it will get the data faster and easier. And it also have two important things, rebalancing and replication factor. Rebalancing is like, suppose the disk got filled up, we need to add more cluster. How do we do? We add a cluster. Then what? We need to balance with all nodes again. We need to distribute the data to all clusters again. It does it. It does this. It even distributes the data across all the cluster. Replication management, every 10th heartbeat from a data node to the name node is actually a block report. With the block report, it's gonna find a block unreplicated or over-replicated. So it will manage the replication. Now, we have a secondary node. It is for two main reasons. One is for backup of name nodes. Suppose if name node fails, there is always a secondary node. And one more thing. When this name node is functioning, sometimes, like what secondary node does is, it will always keep a image of a name node metadata in it. And whenever a new updates comes up, it adds into it and updates to the name node, so that name node will come to know, yeah, okay, fine, this is what happened, yeah, okay, fine, this node is added, okay, fine, this is the new clusters formed, okay, fine, I got it. All these things will be updated by the help of the secondary node. Data nodes are workhorses. They write the data, they retrieve the data from the blocks and get back to the client. Okay, now HDFS interaction. HDFS interaction, it has a FS shell, which is a standard Unix bash shell, allows to deal with HDFS. Hadoop FS is a you know file system command file system shell, which helps us to access Hadoop environment, which are examples like copy from local, which copies the data from local to Hadoop, copy to local, like which copies Hadoop data to local, move data, copy data, put the files into the Hadoop, I mean remove the files RM, and then Hadoop FS abstract. This is like administration shell, which helps us to move, delete files, open for write blocks, like move is for move corrupted files, delete is for delete corrupted files, files for print out any files being checked, open for write is a print out open for write. All these things will comes up. You can see always in the Hadoop site for more commands, and you'll have a clear picture. They have a beautiful documentation there. You can always read the documentation and make your work done. MapReduce is a programmable framework pulling data in parallel out of cluster. I mean, it has a job client. Like a job client, it submits a job tracker masters. To task trackers. Like the job client will always tell the job tracker that I want to put the data. Okay, this is while telling this, job tracker will come up with an execution plan, like what are the nearest nodes, what are the best replication factor I can get from all these nodes, coordinate with the nodes and schedule their availability to work on it, and also do phase coordination. This is very important, very important. What is phase coordination? Phase coordination is you know um, which is to make all nodes synchronized, like they do on the same phase, like all the nodes doing map phase. Once every node complete map phase, you allow nodes to go into reduce phase. So that is the important thing job tracker also does. At the same time, while job client is giving this information to job tracker, it puts the binary file into Hadoop ecosystem. Now, task trackers. Once the job tracker told them, this is the, once they understood the commands from job tracker, then they start working. They grab the binary file, cut the binary file, get them, and map them, reduce them, and fill them, and fill the blocks in them. So job client submit the job. So once again, like clear picture. Job client submits the job. A job contains the uh, compiled binary which contains our map and reduce functions and some configuration information that will drive the job. The job tracker's responsibility is to come up with the execution plan. Like it's gonna coordinate, it's gonna schedule jobs and across the task tracker, and also does space coordination. Task trackers are the ones which break down the jobs into tasks like maps and reduce tasks. Every task tracker has a slot on it. Task trackers will take the map and reduce functions out from the compiled binary, throw them into these task slots, which actually do the execution of map and reduce functions. They also report the progress back to the job trackers. It's like very resilient architecture. If something fails, the job tracker will know about it. Reschedule the task on another task tracker. It has 7 important steps. We'll see one by one. So, step 1. Client submits the job to the job tracker. Okay. Also in the background, it's going to copy the binaries that contains the mapper and reducer implementation along with configuration information, input and output. Uh, I mean, like information like how the input and how the output should be. Inside the HDFS, like step 2 is job tracker will query the name node. Hey name node, I need the locations and mm, the the name of the data nodes that contains the data I'm looking for. It's going to ask first the client and first the closest to task trackers. If they do not, they go for rack locality. If they don't have, they go for cross rack locality, which means like it's gonna pick up the nearest cluster that has available stars. Okay, then it's gonna create an execution plan. From there, the task trackers take over and do the work. Task trackers will execute their map reduce codes, send data through map reduce pipeline. So this is what I said, the map reduce pipeline. While it's executing, it sends its status report like heartbeat to the job tracker, info about the task, what phase it's currently in. This is the phase coordination I mentioned. All maps like should finish first the map phase and then come to reduce phase. Without completing all the map phases, it cannot make it a file because it may lose the data. So it needs to be phase coordinated. So once all phases finishes, the job tracker updates the status. These are the 7 important steps it has. Map reduce internals. So it has a split phase, map phase, shuffle phase, reduce phase, output format. Split phase. The input data is divided into input splits based on the input format. Input splits equate to a map task which all run in parallel. We can have thousands of mappers running. Input format describes how the files are passed into map reduce pipeline. Map phase transforms the input splits into key value pairs based on user defined code. Shuffle and sort moves map outputs to reducers and sort them by the key. Reduce phase aggregates the key value pairs based on the user defined code. Output format determines how the results are written to the output directory. Let us see the whole flow by an example. Suppose we have this file. This file is in the input phase to split phase. It will be divided into these 5 lines. Will be divided into five splits, and then map phase. Each one mapped with the number 1, which is sorry, I didn't mention how to all these. These are also will be paired with 1, which indicates that nug is a word which is single time presented in the split. And then it will be using shuffle or sort, which will make all of them into a split. Shuffle into individual words, like nug will be separated, sys will be separated, line will be separated, all these things. Then reduce phase. It's gonna reduce them into a number of such keys exist. So it's gonna pair them. So it says like we have 2 sys, 2 have 2 line, 3 mag like that, and then it picturizes and puts like this into HDFS environment. So we also we also have a combiner phase, which is middle before getting a reducer phase. Like suppose all these are in a different. Suppose a file A is available in one data node, two times, and in other, two parts are available in one data node, or like two times the file is there in the, not the file exactly. Suppose a word called nug, which is there 2 times in node 1, 3 times in node 2. We cannot come up saying it has it has a two. It's better always to make a reduced picture, which is what a combined picture in each individual node. Say the nug is having 2 times in the first node, in the node A, and similarly node 3 will combine and say I have 4 times the nug is there. And now, while shuffle phase, it totally, while in the shuffle phase, it totally combines those things. Saying here we say nug 1, nug 1, nug 1. There, if nug 1 is there in the same PC, it could be nug 1, nug 2. You got the picture. These two will be combined in the previous page and comes as nug2, so that nug1 nug2 will be at just 2 items. It saves a lot of bandwidth, and in the reducer phase we directly get the nug3. Got it? So that's the picture. And that's it on the theory on MapReduce and HDFS, and we'll see next time on how to work on HDFS ecosystem with some commands, getting the data into HDFS system, and then I mean doing some MapReduce jobs, and then all these things we'll see in the next series of videos. Have a nice day. Take care. Bye. Bye.